Hello guys, welcome back to Coding with Bobby, and today we are discussing our daily LeetCode challenge, that is task scheduler. So we're given few tasks, CPU tasks, each represented by the letters A to Z, and a cooling time N. Each cycle or interval allows the completion of one task. Tasks can be completed in any order, but there is a constraint: identical task must be separated by at least N intervals due to cooling period. Okay. So we need to find out the minimum number of intervals required to complete all tasks. Fine. So we're given A and B and B, and N is given as 2. So we're given that there are 3 A tasks and 3 B tasks. Now the constraint is that between any two A tasks there should be 2 intervals, and between any two B tasks there should be 2 intervals. So if we just normally casually observe it, how we can solve it would be like A, then it needs 2 intervals, then again A, then it needs 2 intervals, then again A, like that. Now for B, same way, what we can do is I can put B here after A just to like not keep the CPU idle. Instead of putting B here, then again doing 2 like that, instead of that I'll put B here, right? Then B needs 2 intervals. One interval is this, one interval is this, then again B here, like that, and again I can put B here, like that. So you see, between any two consecutive A we have got 2 intervals, between any two consecutive B we have got 2 intervals. So this way we can solve this. Now we'll take one more example. Suppose we have A, C, A, B, D, B, and N is given as 1. So between any two consecutive A's or B's or C's we need 1 interval. So A is coming twice, and B is coming twice, and C is coming once, and D is coming once. So the best case would be I should take the maximum one and I should place it first. A, then it needs 1 interval, then again A. Sorry. Now is B. Now B I can place here. Sorry. And then B I can also place here. Now I've got C, which can be placed here, and then I can have D right here, because C only has 1 instance, D also has just 1 instance. And okay, let's take the last example as well. A, B, 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 and N is our 3. So we can place A here. A's and B's are coming thrice. Then we need 3 intervals, then A, then we need 3 intervals, then A. Okay, and B, I can put B here, then 3 intervals, 1, 2, 3, then B again here, 1, 2, and 3, then B again here, like that. So you see the total number of intervals needed here are 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, that is 10, right? And here it was 1, 2, 3, 1, 2, 3, and 1, 2, that is 8, like that. And here it was A, B, C, D, that is 6. So in such cases, what we are doing here, I'm going to show you 2 approaches. First we'll see the priority queue approach. See, when we are just taking care of like which is the maximum frequency element after one another, then we'll make use of frequencies and priority queue. So we'll just move to the solution, then it would be more clear. Frequency, and there are only gonna be capital letters, so we can take 26 length for char ch tasks, and I'm just gonna do frequency ch minus a plus plus, like that. Now I'm gonna take a priority queue for integer, pq, new priority queue, and I'll just put in collections dot reverse order just to make it as a max heap, like that. And I'll put my frequencies inside that. If frequency I is greater than 0, then just pq dot offer frequency I. Now my frequency would have the like something like that, 3 3. A is coming thrice, B is coming thrice, and it will give me the highest frequency first, right? So what I can have is I can have one result. I can just return it like that. Now what I'll do, I'll just do while I've got some task left. Now PQ contains all the tasks, right, with the frequencies. Dot is empty, and I'll just check. See, we are gonna make some cycles here. If we take this example where n is 3, so n is 3 means if I place my a here, then how many more needs to be placed? After that a should come. 1, 2, 3, then a should come. So these are 3 and plus 1 a itself. So that means this cycle, we are forming cycles, then another cycle will start. So we are making some cycles of n plus 1, like that. So I'll just take one int cycle is n plus 1, and now what I can do is okay, I'll just start popping out from my priority queue while not pq dot is empty and cycle is greater than 0. Yeah, because we only need up to that cycle, right? And I'll also take one list. I'll show you why this list is needed, which will store to be added. New array list, like that. Yeah. So I'll just get my current pq dot poll, and if current is greater than 1, I'll add it to be added dot add, and I'll just add the cur minus 1, and we'll do cycle minus minus or minus equal to 1. Now you see, suppose I've got 3 instances of A, 3 instances of B. Now I've put one A, right? It will give me A, 3 frequency. That means once I've already put it, now 2 frequencies should be left. So I should add back to my priority queue. I'd add back this to priority queue later on after this while loop with minus 1 frequency, as 1 has already been added. And if we are only left with 1 frequency, that means we have taken it and now it's done. We need not add it again. Like that. Now what we'll do, we'll just take all the integers from here, int, and I can task to be added. And we'll just do pq dot offer and task, like that. Now you see I have already added all the tasks that are remaining with their frequencies. And now I'll just check if my pq dot is empty, right? If my pq dot is empty, that means all the tasks are done, right? Else what should be done? Now if you see in this case, I placed my A here, then the second highest frequency I can put B, like that. And in my priority queue, I will again add their frequencies at 2 and 2. Now priority queue is not empty, that means tasks are still left, but we need to make some idle slots, like that, right? So in this case, to my result, what should be added? Actually, it should be added whole cycle length. So I'll add n plus 1. If priority queue is not empty, so I'll add n plus 1, like that. And suppose my priority queue becomes empty, and when will it become empty? We'll check that. We'll again place A and then B, like that. Now the frequencies will be left as 1 and 1. Now again I'll do A and B. Now the frequencies would be left 0 and 0, and they won't be added to priority queue. Now the priority queue has become 0 size, right? So now I shouldn't add the whole length of the cycle because I don't need any of these idle slots here. I just need to add these two. That is the number of elements of the last task added of the last cycle. So I'll just create one int count tasks, and I'll just do plus plus. So these many tasks were added in the last cycle. So in this case, I'll just add count tasks, like that, and I'll just return my res. Okay, there is some network error. Doesn't seem nice. I'll just copy it and I'll just reload it once. Yeah, and we'll just submit it. I mean run it. Okay, I've been logged out. I'm really sorry. I'll just log in real quick. Yeah. And I'll just run it. Okay, we've got some error, return res, and okay, I've already written it twice, no issues. Yeah, so this works fine. We'll just submit it. Yeah, works fine. So this is the solution that came to my mind, and it seems fair enough. But we can see there are so many solutions as well. And this is the solution, the second approach that I'm going to explain it to you, right? Which is of the idle slots that we need. And this is also available in our editorial. We'll just open it as well. Yeah, this is of the idle slots. This is a sort of like mathematical one. Here also we are first calculating the frequencies. Now we have got all the frequencies, right? Suppose I've got A coming thrice and B coming also thrice, right? So what I can do is I'll just place my A here, and then I need A 1, 2 and 3. Suppose N is 3, like that, and then I can again put A, and then 1, 2 and 3. Then I can put A, right? So I'll take the highest frequency and I'll place it on the map or on the screen. I'll just place it, the highest frequency one. A have been placed, and I've also put the idle slots or the intervals between them, right? So if you observe it closely, we can see how many of these total idle slots do we have. 3 plus 3, that is 6 for now. And how do we come to that 6? What I can do is maximum frequency, which is this one. They have sorted it, so the maximum frequency is frequency 25, right? So maximum frequency is 3 minus 1 into n, which is 6, right? Suppose n is 2. So what I'll do, A, then 2 slots, then A, then 2 slots, then A. In this case, the idle slots should be 2. And how we came to it? Maximum frequency is 3 minus 1 into 2. That is 4, like that. So now what we'll do, we'll loop over rest of the frequencies in the reverse order, in the descending order, except this A, right? From the second highest frequency we'll start, and we'll try to decrease these idle slots, right? So suppose I'll start, I'll take this example for now, and suppose I've got 3 B's, right? B I've got 3 times. So I'll just start from I is equal to 24, because 25 is the highest frequency, which is A. We have already taken it into account. Now I'll start from the second highest frequency, which is now B, and that is coming thrice. So if you observe that, what we are doing is we are deducting from the idle slots the minimum of maximum frequency, and maximum frequency is, in this case, mx frequency is the frequency of A minus 1. Minus 1, yeah. And why minus 1 we are doing? Because see, we are only taking these cycles, right? This cycle and this cycle. This A is the last one. It doesn't need any intervals after it, right? So we are taking 2. Now you see, idle slots is minus of frequency maximum or the frequency of the current element. Now the current element is B, which is coming thrice. So we can minus the minimum of frequency, maximum frequency, that is 2, or the frequency of B, that is 3. So we'll deduct 2 from here, right? And why 2? Because B can be placed here, B can be placed here. These 2 B's will take the place of our idle slots, but the last B that can be placed will not take up any idle slot, because this is the last one. We can place as many we want, right? Now suppose I've got, suppose this is the question, right? This is only the question ends here. So in that case, what we can check is if we have still got any idle slots left. Now idle slots are, earlier it was 4, now it has got minus 2, so 2 are left. That means 2 idle slots we need apart from the length of the task. Length of the task was A, B, B, B. So this was 6 and plus idle slots that we need. So answer is 8 in that case, right? And suppose we take the example of A, B, 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 and we take C, C, and D, like that. So we'll come to the third frequency now. And in case of third frequency, we'll deduct from minimum of maximum frequency, which is 2, comma 2. So we'll again deduct 2. So 2 minus 2 will become 0, right? So idle slots are not left now. Why? Because 1C comes here and 1C comes here. Now we have got D. Now D is only coming once. So we'll do idle slots will be minimum of 2, comma 1, which is 1. So we'll deduct 0 minus 1, which is minus 1. So that means D will not occupy any idle slots. It can be directly added to the end. So this will be our answer, like that, this one, right? So now in this case, our idle slots had become minus 1, less than 0. So if our idle slots is less than 0, that means we don't need any additional intervals or additional idle slots. We can play around with these only, with the length of the task, and we can frame them, or we can execute them in such an order that we don't need any extra intervals between them. So we'll just, if the idle slot is greater than 0, then in that case we'll add task.length plus idle slots. If it is less than equal to 0, in such of our case, that is minus 1, in that case without any idle slots we can place it. So we'll just return task.length, like that. So the code is pretty clear. It's right here. I won't be writing it again. I just wanted it to explain you this, right? And this you would have got how we came to this. I'll explain it again. Suppose we have got A, B, 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 and N is 3. So A, then 1, 2, 3 slots, A, 1, 2, 3 slots, then A. So this A will keep out as it is the last one. We are not considering as part of any cycle. We don't need any interval after it. So we'll only consider these two A's, which is the highest frequency minus 1. So 2 into N, that is 6, like that. So I hope this question is really clear to you. If there's any doubt, just let me know in the comments. Thank you.